Hello guys, Science Fist here. So today we are going to be looking at momentum and impulse. This is for grade 12 physical science. So we basically going to discuss what momentum is, the basic definition of momentum. We are going to look at Newton's second law of motion in terms of momentum. I think this is one of the most important concept and one of the things that matriculants struggle with. And then we're going to lastly look at the collective perspective of momentum and impulse, how they actually work together. And we're going to look at momentum now. So momentum, this is basically mass in motion. Okay, so mass in motion. So mass, will be looking at weight, or rather we are looking at weight of the object. So weight of object, and then motion would be the velocity, right? So all together we have momentum, which is abbreviated by P, would be mass. So this will be momentum, and this will be the mass, and this will be velocity of the object. Okay, so momentum, that's mass in motion, basic definition. This is the sign that we use for momentum, P. The mass is m, and then v is your velocity, right? So P, or momentum, is directly proportional to the mass, and P, your momentum, once again, is also directly proportional to your volume. So in that case, I mean, if you double the mass and keep the velocity constant, you also increase the momentum by double. So if you also double the velocity and keep the mass constant, you also double your momentum. So that's what I mean by the momentum being directly proportional to both the mass and the volume. It can also be defined from the equation as saying the momentum is basically the product of mass and volume of the product of mass and velocity of the object. But I'm not really going to stress you about definitions. I know this is something that you can go over. I really want you to understand the concept rather than just trying to teach you definitions, which you can basically do on your own. So that's about that. I'm quite sure this is nothing too hectic to do. So that's basically all I wanted to say about momentum. Now we're going to look at momentum in terms of Newton's law, second law of motion. Okay, so now we all done with that boring stuff, the definition of momentum, the signs and whatnot. So now this is really where it sort of start to get interesting, when we are looking now at momentum in terms of second law, second Newton's law of motion. So we know that this is the equation of second Newton's second law of motion. So this is the equation that we are all used to. I think you also did in grade 11. What you're looking at here is, I want you to look at these two quantities there. Okay, so your mass, that's fine, we don't really worried about that. Your acceleration, remember your acceleration is the change in velocity per given time. So we can rewrite that as this delta v divided by delta t. So now this is replaced by the acceleration. Okay, but now I want you to look closely at this that I'm putting around the dotted lines there. Okay, that looks familiar because remember we said momentum is equals to P m times v. Okay, but we realize that here we have a delta. Okay, here we don't have a delta, and that's really important because sometime when we now get to questions and then you look at, let's say you are given delta v, you can't use that delta v to calculate momentum. You use v to calculate momentum. Delta v and v are completely different things. So delta v here and v there, they are completely different things. So what happens is, when we have now delta v, we're not going to equate this whole thing as p. We're going to equate it as delta p. Okay, delta v. So now we will say F net is equal to m, and now remember what I said, in terms of a, we're going to write delta v divided by delta t. Okay, we know this, that's the definition of acceleration. Okay, then now we're going to take our mass times delta v and consider that in terms of momentum. That will be change in momentum. Okay, so if we do that, then we're going to end up with, instead of m times delta v, we're going to end up with delta p over delta t, and that's F net here. Okay, then now if you have, we can now write it in terms of, you can write it like this: delta p F net delta t. Okay, so this is also Newton's second law of motion. Okay, this equation is literally the same as that. We just derived it, we just wrote it in terms of momentum. This is also the same as that. We just referred it or changed it in terms of change in momentum. We will realize that change in momentum is actually equals to impulse, but I'm going to explain that now. Okay, so let's get things right here. Delta p is not the same as p. So p is momentum, delta p is change in momentum. These two are not the same. Okay, don't confuse the two right there, because p is equal to m times v, and then delta p is equal to m times delta p is equal to m times delta v. These two are not the same, guys. I repeat, they are not the same. Don't mess up in your exams and try to bring these two together. For you to get delta p, you need two of these: your initial momentum and your final momentum. Then you can subtract the two to get your change in momentum. But don't try to get your change in momentum if you don't have a change in velocity. If you only have one velocity, then you stick to that one. You're not gonna get change in momentum, but you're gonna get momentum. Okay, I've seen this, a lot of people, they struggled with it. It sounds stupid as I'm saying it, but really you need to be careful. Delta v and delta v and v are not the same. Delta p and p are not the same. So now we realize that we can write Newton's second law of motion in terms of momentum. Okay, so don't be shocked or don't be nervous when you get a question that is asking you of momentum, yet you are working with the second law of motion, a kind of question. It's totally possible. You just equate this to ma as well. So if you get momentum, you can still find the resultant force. If you get mass and acceleration, you can still do that. Let's say you don't have acceleration, but you have time, you can do that. If you have time and momentum, you can find that. If just work with this. Okay, but now what I want to move on to is when we rearrange this equation and we write it in terms of change in momentum, which is F net, it's called, or F net multiplied by change in time, which is, we just multiply this and that, guys. Simple algebra there. Delta p. Okay, so once we've reached here, I did mention that this is actually equals to impulse. Okay, but then you ask me, what is impulse? Well, impulse is the, you know, when you collide with something, you're going to experience a force. So if I take an object A and object B here, when these two collide, right, they're going to exert a force on each other, and that force will be experienced the same. So that force is actually F net. Okay, so the force that is experienced by these two objects when they collide at the exact moment when they collide. Okay, so what happens is, if the two objects collide, they take a certain time, delta t, to actually come to a stationary point. Let's say they collide, and then after 0.002 seconds they come to a standstill. So then this is the interval that we are looking at. So what it really is the force over time for which the force acts. So the force over time at which the force acts, that is moment, that is impulse. It's quick, it's rapid, it's a very quick incident that happens like quite fast. Okay, so that was it. This was the introduction video, if you want to put it that way, to this topic. So what I'm going to do next is I'm going to look at types of collisions. I'm going to do the collisions type of questions, and introduce you to some other new concept, inelastic and elastic collisions and all of that. So yeah, that's about it from you guys. All the best with the studies. Keep working hard. Don't forget to like, comment, share and subscribe. Until then, see you.